Hello and welcome to Energy Use for Sustainability 310. In this section, we look at the various sources of energy, both renewable and non-renewable. And in the chart before you see on the left-hand side, we have renewable energy, which is sources of energy that can basically, once used, can be replenished fairly easily. On the right-hand side, you see non-renewable energy. And of course, the big one out of this is coal, which comprises the biggest category of where we get our energy from for electricity production. In other words, the largest source of our electricity production, the electricity that we use in our homes, comes from coal. Nuclear power used to be a pretty major source, although we have not built a nuclear power plant in some years now. Increasingly, we are focusing more and more on wind. Wind is a huge contributor to our renewable portfolio, as well as solar, or rather solar that is specific to residential areas. In this chart, we look at the percentage of energy consumption that is accounted for by the United States. And this is a lot, as you can see. We are something like 1/20th of the world's population, 5% give or take. We produce about 15%, and we consume about a fifth. So our production is disproportionate to our population, but also is our consumption. We consume a lot more. So where is this energy coming from? Why is energy important? Because energy accounts for the vast majority of greenhouse gas emissions. Here you can see something like 80% of greenhouse gas emissions, this orange area here, are due to energy. Here I wanted to just go over some basic conversions for energy. I'm not going to expect you to know these in any great detail, but I just wanted to share them with you because energy can be measured a few different ways. The ones that you are most familiar with, the one I'm going to ask you to probably, not probably, the one I'm going to ask you to measure in your household is kilowatt hours. And here you see kWh. Kilo means thousand, and then watt is 1 joules per second an hour, of course. You know what that is. The joule is broken down further right here in case you are interested. But basically, 1 kilowatt of energy is the energy expended over an hour or 3,600 seconds. Here are some more conversion factors in case you're interested. In the US, we use a system of classification that is a bit different than the rest of the world. The rest of the world, or most of the world, uses the metric system. So here we have conversion between US units and metric units. Some other conversion factors as well. Petroleum here. For example, a barrel of petroleum, how many gallons of gas is that, and so on. Ton also sometimes you will see used in the literature or in colloquial speak in the news and so forth. Short ton, long ton, metric ton all have a few different meanings. 1 kilogram is roughly 2.2 pounds, right? So 1 metric ton would be about 2,200 pounds, somewhere between a short U.S. ton and a long U.S. ton, right here in that range. Or rather, a long ton is approximately 1 metric ton. This is a sample bill for electricity usage. This was taken a few years ago, and actually this is taken from my office, and you can see that this gives you the kilowatt hours used right here on the bottom, a number of days for which this reading was taken, an approximate number of kilowatt hours per day that were used. And you can see that, again, no surprise, Southern California, this tends to peak July, August, September. Why is that? Well, air conditioning, right? Air conditioning uses quite a bit more energy than other appliances. At the peak, August, 49 kilowatt hours were used. This is approximately, let's see, the least amount was used in November. It's getting kind of cold, but not very cold, so you're not using the heater also necessarily at that time. If you have an electric heater, that can use up a lot of energy as well. So you have around 22 kilowatt hours here, and then in February, that's a 27 kilowatt hour difference between the peak usage in August, right? So it's almost doubled essentially during that time of the year. The sample bill again looks at the breakdown of the electricity usage, and you can see there are lots of different charges here. And and often we will in the U.S. use a tiered electricity bill. What that really means is that sometimes the more you use, the more you pay. The kilowatt hours, the charge per kilowatt hour, which are shown right here, are different based on, of course, geography and who your utility company is, but also what time of the year it is and how much you use. So sometimes solar panels will not make sense to a household that doesn't use as much electricity as a household that is fairly big, say 3,000 square feet, and also uses something uh, and is located, let's say, in Phoenix, Arizona, and where you use a lot of electricity throughout the year for cooling reasons. But also you have access to the sun, right? Much more than you do in other parts of the United States. Here we look at total energy consumption. Again, in terms of British uh, thermal units. That's what BTU stands for. And again, this is quadrillion, by the way. Quadrillion. Remember, million, 6 zeros, billion, 9 zeros, trillion, 12 zeros, quadrillion, 15 zeros after one. So quadrillion British thermal units, and this has gone up again quite a bit over time in the United States in 1950s and then 2010. This, of course, should not be a surprise because we've also had population growth during this time. One of the questions, of course, then that you should be asking yourself then is on a per capita basis. In other words, in a per person basis, how much has our energy growth gone? When we look at water later on, one of the things that we'll see is that even the water usage has gone up because all usage should theoretically go up as population increases. More people, more usage of energy, more usage of water. Our per capita usage actually of water, at least, has gone down. In this chart, we look at the breakdown of U.S. energy consumption on a per capita basis. Again, this is 2010 data, and the sources of that energy. Where is that energy coming from? Now, remember, we use energy kind of in a broad sense. If you think of energy in a household basis, or you limit it specifically to your household, you're really talking about electricity production for the household. But again, energy is used for a variety of things: industrial processes, household electricity production or usage, but as well, the biggest category is petroleum. And again, that is for not household necessarily, that is for transportation usage. So if you take out petroleum, you're taking out nearly 106 kilowatt hours per day per person out of the total per capita usage. So petroleum by far is the biggest contributor to total consumption. But coal is the biggest source of, as I pointed out earlier, of energy, or the biggest energy source for electricity production for the households in the United States. Okay, continuing with our story here, we look at the next slides, which also look at U.S. energy production by major resource. So here it's interesting, in this first slide, most of the energy that is used on a per person basis daily comes from petroleum. Natural gas is about 24% in 2010. Now what's happened as you fast forward 10 years or so, this data is a bit more recent, you notice that natural gas has really kicked up, right? And this is probably, you can guess, due to the increase in natural gas extraction in the last few years due to things like fracking that you have heard about in the media. So there's some change in this in energy production by source over the last decade or so. This looks at consumption by energy source in 2017 now. It's a little bit more recent again. The renewable portfolio here is about 11%, which is not great, but it's not bad either. And this is total, not just household. Coal is 14%, natural gas 29%, which is more closely aligned with the production here that you see. And petroleum, 37%, which is going back about 10 years. Right here, petroleum, 39.8, 40%. This has gone down a bit in the next in the 10 years. Sorry, I'm switching back and forth here, but in the 10 years between 2010, or 7 years or 8 years between 2010 and 2017. So petroleum still continues to account for the largest source of energy production, though natural gas is being produced at ever higher rates recently. Why is that? Because though we have cars or automobiles, conveyances that are powered by natural gas, petroleum is by far overwhelmingly the source of energy for transportation. So in summary, this is a bit confusing. Sorry to kind of jump back and forth between the slides, but um, petroleum continues to account for the largest source of energy production, though natural gas is produced more than petroleum because most cars, trucks, and automobiles still use petroleum. This chart looks at the trend historically, 1950 to 2015, in U.S. primary energy consumption by major resources. So renewables have made a pretty good headway. This is that green space at the top right here. 1950s till pretty much mid 1980s, 1990s, not much of a change in the renewable use. But as we move forward from 1990 onwards, you see there's an increase, and especially in the last 10 years or so, quite a bit of inroad made um, by renewable energy consumption. Um, the other big one here, of course, is petroleum. Petroleum is still a pretty prominent part of our energy portfolio, as is natural gas has become much bigger. You see this light blue right here. Coal was pretty big in 90s and 2000. There's a slope right here. You can see that. It's increasing from the 1960s all the way to 2000, and then it starts to really drop off. What is filling in the gap? Natural gas, renewables, and even nuclear, right? We're not adding new nuclear sources. It's just that as the importance of coal has dwindled, the nuclear consumption, along with, of course, the other natural gas and petroleum, has relatively gone up compared to coal. Um, this looks at energy sources for California in the last. Sorry, excuse me. This looks at energy sources in California in 2012, and kind of the take-home message of this slide is that California has been getting a lot of its sources from the same sources that the United States traditionally does, which is, again, coal, petroleum, natural gas, and so on. In electricity production, however, what the state has been doing because of its renewable energy mandates, it has been actively trying to transition into a renewable portfolio. So the mandate is that by 2020, about a third of our electricity should come from renewable sources. So in this regard, California is a bit of a pioneer, especially when compared to other states that are more in the Midwest, that are still more reliant on traditional sources of energy. So we're saying California is a leader in the transition to renewable energy. Roughly a third of this is supposed to come from renewable sources by 2020. Today, if you look at California, energy production, renewable energy, which is at the bottom here, roughly 900 trillion British thermal units come from renewable energy. So we're well on our way to producing a significant amount of our energy from renewable sources. We lead the nation, right here, you can see the highlight right here, in solar capacity, energy produced from solar energy. Roughly 73% of the nation's capacity comes from solar energy. We also are up there in hydroelectric generation, and second in net electricity generation from other renewable sources. And first, as a producer of electricity from solar, geothermal, and biomass. Biomass is, when we look at renewable later, biomass is using things like wood, things that have an organic component to them for energy production. Now, a lot of biomass is not necessarily used for energy production that is used at the household level. Often industries will recycle the waste products that they produce, biomass, and use it for energy production locally. So though we are producing a lot of energy from renewable sources, we're also using, and some kind of interesting statistics really highlight this. You look at the amount of energy that we use for jet fuel, for example. We account for 20% of the nation's jet fuel consumption. So this is of course a product of, we have the most people of any state. But we're also a high energy user because we have a lot of industries. We have a lot of different type of diversified industries. We have Hollywood, we have Silicon Valley, we have biotech in San Diego that use energy very significantly. So it makes sense that California would actually transition to a renewable portfolio as we are also producing a very large amount of climate change um, because of our industrial and residential use. Here we look at California consumption by end use sector, transportation, 40%, not much different than the rest of the nation. Commercial and industrial are roughly 1/5 and 1/4. Residential, which is you and me, basically almost a fifth, 17%, 16 to 20%, somewhere in that range. And 40%, of course, is for transportation. If you look at state energy consumption per capita, this is in 2010. The U.S. is shown in yellow. On a per capita basis, California, New York, again, the most populated states, Florida is right here as well, are ranked really towards the end. And this is true of water as well. The biggest consumers overall, because of, again, size, right, is California, Florida, New York, Texas. But in terms of per capita, when you divide the total consumption by number of people, California falls way low. However, Wyoming, Arkansas, Louisiana, North Dakota, Iowa, interesting, right? Where are these states located? And Texas are very high on a per person basis. Why is this the case? It has a lot to do with actually density. And that's sort of the big picture here, or big story here, is that when you spread out people over a very large landmass, it is expensive to transport energy from where it's produced to where people use it. It's expensive to transport goods and services in low density areas. So low density areas are always going to have a high per capita consumption of energy, high per capita consumption of water and other natural resources. Here we look at the energy production and consumption of different types of energy sources by end use sector. In other words, petroleum, for example, the vast majority, 72%, goes to transportation. No surprise there. Coal, on the other hand, 91% of coal goes towards electricity generation for mostly residential uses. So each type of natural resource is used in very different ways. Natural gas, however, is split a bit more evenly between these end use sectors, right? You look at natural gas, only 3% goes to transportation. This will increase in the coming years as you have more natural gas powered automobiles. But about a third, 35%, goes to industrial. Another 28% goes to residential and commercial, and another third goes to electricity generation. Okay, electricity generation, and this is for natural gas. One quick clarification here: you have electric power and then residential, commercial. This electric power is primarily for residential use. However, this residential and commercial sector includes heating, direct heating, right? So you have natural gas, 28% going to residential, commercial, and then renewable energy, 8% going to residential, commercial. This is primarily for heating and local commercial electricity production. So sometimes you'll have, some type of business that is large enough to have its local electricity generation. Schools also do this, by the way. They would sometimes fall in this category. You'd have to disaggregate it. But if you look at the flip side of all of this, which is 100% of nuclear power goes towards producing electricity, right? However, nuclear power only accounts for 23% of the total electric portfolio. Roughly a third of that used to be as high as 40%, in recent years has gone down, comes from coal, right? Coal. 91% of coal goes to electricity production, 100% of nuclear power goes to electricity production. But when you look at total electricity production, only 34% comes from coal, 23% comes from nuclear power, and the rest come from the other sources. Petroleum, only 1% is used for electricity generation, right? The vast majority goes to transportation. It's a bit complicated, this chart, but hopefully it's a bit clear. This again looks at end use again, which are the biggest uses of electricity. Transportation, again, no surprise. This looks at household energy consumption by source. Natural gas, again, is for heating. Electricity is, of course, for electricity. So the two biggest sources are electricity for all your appliances, and in some cases heating, and the natural gas for heating. This looks at, data is a little bit old, but it looks at consumption per by household, by region. And again, not a surprise, the Northeast and Midwest. This is primarily because they have low density, and also their heating needs are much more significant than the West and the South, right? So heating is a huge, huge consumer of electricity. Here we look at, and earlier, if you remember, I was talking about water per capita usage of electricity. I'm sorry, that came out incorrectly. Per capita water usage over time has actually gone down. And here you look at per capita household usage over time, and we used to be much higher. It has also gone down. And this is not a function necessarily that we are using less electricity or appliances have become more efficient. Though that is the case, appliances do use a lot less electricity now than they used to. However, this is also a function of increasing densities. As people move to cities, places urbanize, you have sufficient densities where the cost of transporting energy or even water drops. So you have less loss over time of both energy and water, coupled with an increasing efficiency in appliances. And what you have is a drop in per capita, or in this case, per household production over a period of years. It'll be interesting to see how these efficiencies and these densities sort of play out in the coming years. Here you look at just specifically household energy consumption by end use. And as I was saying, heating is a huge thing. Look how high heating is. It's right here. Appliances, electronics, and lighting, of course, are going up. We have more and more TVs, right? Got to watch Netflix. But heating, space heating, water heating, pretty high. Air conditioning is there. Everything is going up, but heating is the biggest category, although it used to be a lot higher in the 1970s. This looks at energy consumption by end-use sector, and here we have residential, commercial, transportation, industrial. An interesting thing that this also shows is the electrical losses. So you see how high this is, right? Right here for residential, pretty high. Electrical losses, commercial, pretty high. Okay, petroleum and transportation, story of a love affair that has continued. Natural gas has gone up a little bit, but it's just a blip, right? As we saw in the last set of slides as well. Industrial, sort of a mixed bag here. Electricity, coal has gone down, electricity's gone up, losses have gone down, but they seem to have flattened out here. Residential losses have gone up, the slope is positive. Petroleum for industrial, gone up, flattened out, gone down. Natural gas, very similar trajectory. Right, so the story of energy production and energy use, there's sort of two separate pieces. And we have to disaggregate production by source, whether it's petroleum, coal, natural gas, nuclear, renewable, and also by end-use sector, commercial, residential, industrial. These all use electricity. However, the sources that the electricity or energy comes from, sorry, I should not just say electricity, energy comes from is very different. Right. So when we talk about sustainability, we have to look at sort of a complete picture that includes, okay, what are we trying to address? Because we could put solar panels on every house. However, that would still not make a huge dent if we don't address the transportation sector, for example. Okay. In the next set of slides, and I'm going to actually stop here, but in the next set of slides, I'll go through them very briefly. We look at the energy footprint of an electric car, and we use the Chevy Volt as an example. I'll let you go through the calculations yourself. It's important that you kind of figure out how to do this yourself. But the take-home message here is that electric cars are good, hybrid cars are good. However, the main thing to sort of remember here is that if you are plugging in your electric or hybrid car, well, hybrid you won't plug in, but electric cars to a grid, right? And this goes back to the earlier story. If you're plugging into a conventional electricity grid, you bring your electric car home and you plug it into your socket at home, if most of the energy in your home is coming from coal, right? Not directly, of course, you don't have a coal plant in your backyard, but if your utility is getting its energy from coal, then the net carbon, the net impact of that electric car that you're using has been minimized. It's been greatly reduced because the electric source you're using, it may not, the energy source you're using may not be petroleum anymore. It's electricity, but if your electricity is coming from coal, you can see it's kind of counterproductive. Now, if you have solar panels in your house and your house is completely off the grid in some way, then the contribution of the electric car towards sustainability goes up significantly. So it's important to consider these kinds of factors. And of course, there are other factors as well with electric cars, hybrid cars. There's their components, their batteries, how they're made, and the impact on sustainability or the goals of sustainability of their individual components in their cars. So sometimes you'll hear arguments that these lithium batteries, the way they're produced, are not very sustainable. That their carbon footprint is still pretty significant. So, of course, as a consumer, it's kind of hard to explore all of this. So we feel good when we invest in an electric car, and there's nothing wrong with that. But if we are going to make major inroads into transitioning off coal, for example, we have to look at the overall impact of all of our consumer items, not just cars, of course, and how they interact with various sources of energy production. Okay, more to come, and we will look at renewable energies next.